Hello all, welcome to my channel. I am back with another video. In this video, we will see how we can debug a Spark jobs runtime and improve it if needed. The intent of this blog is not to give you this exact 60% number. I just wanted to give you an idea how we can do uh, job analysis and then improve it. Uh, And in this particular example, we will be seeing that how we went from 33 minutes to 12 minutes by doing some analysis and tweaking our job. So let's get started. So the query that we had, we were trying to, it is a very common query that it comes into any ETL analysis or any data analysis that we do is something like find the top one in each category based on certain condition. This was the basic fundamental question. And the solution that was implemented to this to achieve the goal was using a window function which handles uh, this group by per category option. So what we have done is we have a window function where we apply row number over a partition and we order by some columns. Then we get a rank and then we provide that rank as one as the output. This is what it is documented in here, that this is a simple query. The goal of the above query is to find the top record in each combination. Combination is based on this column 1, 2, 3, 4, which is on which this partitions are created. So what it does, this query basically does it will split the data set into multiple partitions based on these keys, column 1, 2, 3, 4. Then it will order or it will sort the partitions, sort within the partitions based on these three columns, sorry, 5, 6, 7. Then it will assign a rank or a row number based on these ranks. And then it will filter out all the uh, rows where we have a rank is equal to 1. So this was the query. And although the analysis that we are doing, this is a disclaimer that we are doing an analysis on Databricks query profile, but this similar exercise can be done on Spark History Server. Not, I will say screen by screen, it is similar. There are some intuition that you will have to apply while we are working with Spark History Server, but the same analysis can be done there as well. But with DBR's query profile, it is very easy because things are uh, displayed in and we don't have to analyze. They are already analyzed and they are presented in a ready format for us to be consumed. So this is just a disclaimer. So what we noticed is that this job was taking around 35 minutes. To be exact, it was taking 33 minutes and 20 seconds. And when we open the query profile, we see that, okay, we were reading 150 GB of around data. We were doing something, total wall clock was 33 minutes, other things. And when we kept on scrolling, you will see that the things that gets attention is that we are spilling to disk of around 400 GB. So this 400 GB, which is spilling to disk, is something which caught our eyes. And the reason for that is that our input source was only 150 GB and we are spilling to disk around 400 GB. And whenever this happens, the reason, most likely reason that is there is Spark is trying to do some intermediate calculations, or it is doing some transformation, and during the transformation it is storing the intermediate result for further computation, and that intermediate result is more than 150 GB or more than whatever is needed, whatever can fit in the memory, and hence that gets spilled and that gets written to the disk. So that's what it was happening. To find out which operation is actually causing that, we have an option of looking at the top operators, which is a panel in the query profile itself. And when we opened it, we saw this, that okay, shuffle is consuming 47.8% of our time and sort is taking another 34.6% of the time. So majorly around 80% of the time was going in this shuffle and sort operation. So we found what are the Spark's native operators which are taking time. To find out or to map it to which particular process or which particular line of code in our SQL is taking that time. we drill down further, and we also saw that see the DAG, and the DAG says that okay, data is scanned, then it is doing some sort-based shuffle, then it is doing some sort-based aggregate, then it is doing some window shuffle, window sort, and the results are then being displayed. So this indicates that the window function that we are using is forcing the Spark to shuffle the data, sort the massive partition, and spilling it to the disk. So we identified okay that yes, there is a sort operation which is taking time and which is causing the issues. And while doing the sort, see the number of bytes spilled to disk is around 90 GB. So of those 400 or 500, sorry, 400 that was GB that was getting spilled, this sort itself was spilling to around 90 GB of data. So we found that okay, this window operation is doing the what you call causing this spill, uh, and we will have to optimize that. But before we optimize that, there is one thing that we would like to mention is that and why this sort based aggregate is coming into picture. Or so Spark has concept of when Spark does an aggregate, which it does for window operations as well. So whenever Spark is doing an aggregate, it has an option of choosing three different types of aggregate. One is sort based aggregate, other one is hash based aggregate, and another one is object aggregate. Generally, it will go ahead with the hash-based aggregate because it is very, if the data fits into the memory and the keys are means immutable, they can be hashed, then it will go with the hash-based aggregates. But that requires a lot, means that if the keys on which we are doing the hash is very large, then we will have a hash table which is getting bigger, and that if that doesn't fit in the memory, then it will fall back to the sort-based algorithm. And in the sort-based algorithm, what it does, it will shuffle the data, it will sort the data, and then create the partial aggregates on that, and then give the whole result as an aggregation back to the system. So that is where this sort-based aggregation comes. And in this sort-based aggregation, because we are trying to put all the data belonging to a certain group to a same partition so that we can sort it, that's where the shuffling comes. And after shuffling, we are doing the sorting as well. So there are this shuffle and sort operations are involved in the aggregate, as well as it is also involved in the window function itself, because our window is doing a partition by. So we are putting the whole bigger tables into certain buckets, which is based on the partition by column, which is column 1 2 3 4, and we are doing sorts within the partition as well. So in the within the window also we are doing some partitioning. So hence we will see this shuffle and sort operations happening multiple times in our pipeline, and that's what it was showing in here as well. See shuffle sort shuffle sort. So we had multiple shuffle and sort operations. To fix this, uh, the solution that was that seems to be very viable is using max by. So max by is an operation, is in a transformation, I will say, available in, or a SQL function available in Spark. What it does, it allows us to get the maximum value, or often based on certain conditions that we have, maximum or min, we have also min by function is also there. So we can get the max or min based on certain columns and based on certain ordinal positions based on which the order is decided. So for example, instead of say, this max by column ordinal, we can say max by expression one, which can be a list of operation, a list of columns, and ordinals can also be another list of columns. And this will, what the first parameter in this decides the column name or column names that needs to be displayed, that will be given as an output. And the second parameter is the column on which we have to check the max condition. So if we have multiple columns given, so we will order based on those columns, and that their position also matters. So for example, let's say if we say df.group by aggregate and then we say max by year, so we will get the year of the column of the date rows for which the earning was maximum. Or for example, in this case, we have, if in a SQL, if let's say we have this data A10, B10, B50, C20 as something is there, and then what we will say is, if we say max by X, which is nothing but the ABC, and then sorry, not X, max by X means we are trying to get X value, or which is the columns like this X, A, B, C, these will come as an output, and this output will be based on the column Y, which will have the maximum value. For example, in this case, we will get the value as B, because it will return this y has the maximum amount, maximum value, and the row belonging to that is this one. So this will be returned, and we are only selecting x, hence we will get the b value. We will not get the y value. So this is how the max y works. And the reason why we are saying that okay, we should be using max y for this kind of operation is that instead of collecting all the values and sorting all the rows in each partition, max by does it using an incremental aggregation approach, and hence it does not require that sorting and shuffling part. So what it does, it for each partition it will maintain two values. What is the value within with extreme uh, ordering, and then uh, the other one is the current one. So it will say, it will store one which is the best record and the other one which is the current maximum record. And for each row it will just compare. If the new value that we are saying is greater than the current one, then it will update both the values, otherwise it will keep the current value as it is. This is simple, what we call uh, we in algorithms we have uh, for example, we use two pointer approach to, or let's say we are trying to get the maximum three. How we compare? We compare first two, and then whatever is the max, then we compare it with the other one, and then find out which is the maximum value. So that's the same approach it applies. And because this is only storing the two values which are to be displayed, it does not need any sorting. So this becomes an O of one operation per row instead of O and log n, because we'll have to do sorting. So this improves the performance because it will have lesser number of operations that is happening, and it will also reduce the CPU because from instead of n log n it will become O of n. And because we are not doing sorting, there will not be spill. So if we rewrite the query, which was there by max function, so we will say select column 1, column 2, column 3, or max by, then we define the struct, and in this case a struct is three columns. This was based on which we were doing the ordering, column 5, 6, and 7. And once we get this, what we will get is means we will get the same output that we were expecting, but the things that will change here now is the amount of spill that is happening. First of all, the if you see, the suddenly the time went from 33 minutes to 12 minutes, that is 37 seconds, and this bytes spill to disk is around 297 now. Instead of the 400, it went down to 300. And if you notice in our earlier say here, this sorting phase was causing that 90 GBO spill, which is almost equal because the sorting operation is totally removed. So we are getting, and some other things also got improved. Hence this the spill that was happening earlier for 400 GB, now it is only happening for 300 GB. So this helped us, and this brought down the time. And also if you see shuffle time in total that was earlier happening, so earlier, if you see, we were happening multiple times shuffle was happening. Now it is only happening once, and the shuffle time has gone down to 40 minutes, and hence we were able to reduce the total time. So if you see, by just looking at the query profile, finding out which operator is taking the most of the time, and can we swap those operators, and can we choose an operator which works better than the current one in terms of runtime, we can solve, or we can reduce the runtime. So this was it for the video. This was a quick short video where we just went through a production use case where we had a job which was running for a longer time. By after looking at the query profile, by looking at the operators which were taking most of the time and what operations were happening, based on that we decided to swap the operation or rewrite the code in a different fashion, which resulted in a lesser runtime. So yeah, keep exploring things, and if you like this video, do share it and support the channel. That was it for this video. Have a nice day.